So the first question on 9.3 asks you, it says, suppose the height of football players at your school follows a normal distribution. That's important to know, with a mean of 74 inches and a standard deviation of 2. So what we ought to do is draw a little bell curve, because all of this is going to be about this bell curve. Okay, and this middle line right here is always our mean. Okay, it's always going to be our mean. Now, if I put little lines over here, this is going to be one deviation above and one deviation below. Okay, so this is one standard deviation. And this is also one standard deviation. Okay, negative one standard deviation. So what that means in terms of this is we know that the standard deviation is 2. So if I add 2 onto this, that makes 76. And if I subtract 2, that makes 72. So we now know where one standard deviation is. Okay, now if I make another one, that's 2 standard deviations. And this is 2 standard deviations below, and this is 2 standard deviations above. Well, our standard deviation is 2, so I subtract 2 away from that, and that makes 70. Over here, I'm going to add 2, because our standard deviation is 2, so that makes 78. Now, if I did a third one, this would be 2 less, because our standard deviation is 2, so I subtract 2 from that, and this would be 2 more, so I would add 2 more to that. So now we have it set up as to what these numbers are on the bottom. The nice thing about these numbers is that now that we have those, we also know what percent. Remember our rule, the 68, 95, and 99.7%? So between these first two is 68% of my people. Between the next two is 95% of my people. And the last two contains 99.7% of my people. So I guess we ought to see what the question even says. It says, what percentage of football players are between 70 and 78 inches tall? Well, that's the 95%, because that's the 70, that's the 78. What are the chances that a football player is less than 68 inches tall? Well, less than 68%, so smaller than over here, is not very good. Okay, so 99.7 is between these, so that leaves 0.3 for over here and down here. So if I split that in half, that's 0.15. So the chances are that they're less than 68%, or 68 inches, is 0.15%. Okay, so there's not very good chances that they are. If they are less than that, then they are abnormal for their team. Okay, so we're just saying that most players are between these heights. And if they're not, they're kind of abnormal for the team. That doesn't mean for the whole school, just for the team. Okay? Now, just thinking about this, I had another question that popped in my head. What percent of the players are above 76 inches tall? So here's 76. Remember, this is 50% of my people over to here, right? So halfway, this is 68. So if I split this in half, this would really be 34% and 34%, right? So if I look at this, this is 50%. Everything to the left of this line, everything to the left of this line, that's 50%. Everything between the line to here is 34%. So that means up to one standard deviation is 84% of my people. Okay, so what's the chances that they're above 76 inches? Well, 16% of the people, because I went 100 minus 84. So 100 minus 84, that gives me everybody that is in this range. Okay, so what percent of the people are greater than 76 inches? 16% of them. Okay. All right, question number 2 says, suppose you have a 10-sided dice. 10-sided die with sides showing 1, 2, 3, 3, 5, 6, 7, 8, 8, 8. So there isn't a 4, a 9, a 10. We have an extra 3 and 2 extra 8s. Sketch a histogram of the distribution you expect if you roll this die 1,000 times. So, first of all, let's kind of figure out our probabilities on this. If I have this nice, cool die, there's 10 sides, right? That's what it tells me, is it's a 10-sided die. So the probability of rolling a 1 is 1 out of 10. The probability of rolling a 2 is also 1 out of 10 because there's only one of them. The probability of rolling a 3 is 2 out of 10. Again, a 5 is 1 out of 10. A 6, there's 1 out of 10. A 7, there's 1 out of 10. And an 8, there are 3 out of 10. So if I roll this 1,000 times, so if I roll this die 1,000 times, the chance of getting a 1 is 1 out of 10. So 1/10 of 1,000 equals 100. So 100 of my rolls should be 1s. Another 100 should be 2s. 200 should be 3s. That should be 100. That should be 100. That should be 100. Probability of getting an 8 is 300. So if I mark these as 50s, I don't know why I chose 50s, but I did. And down here, this is my 1, this is my 2s, 3s, 4s, 5s, 6s. There's not a 4s. 7 and 8, so we'll just stop there. I wonder if this will work. I'm going to try something. We'll see how this goes. So the probability of getting a 1. So there's the 1s. The 2s are also 100. The 3s, on the other hand, are 200. Whoa, that wasn't cool. I don't know why that one doesn't work. So there's the 3s. They go up to 200. I'm hoping it works for the rest of them. That was kind of convenient. We don't have any 4s. The 5s go up to 100. The 6s, they go up to 100. The 7s go up to 100. And the 8s go up to 300. Sure, green. Apparently my lines above this somehow aren't connected. So anyways, I have an idea. There we go. So that's what my histogram looks like. So this is, and on the bottom down here, I really should have written like this is the number on the die. And over here, this would be number of times it occurred out of 1,000. So that's my histogram for that. Okay. So now if you wanted to do a histogram a different way, you could have said that this line's at 1.5 and this line's at 2.5 and this line's at 3.5. And then I know that between 2.5 and 3.5 is 3, or you can do it like I did here. So either way works for when you're drawing a histogram. Okay, the next question says sketch a graph of a normal distribution with a mean 20. So I kind of drew a little line. This middle is always going to be my mean, so that's the 20. And the standard deviation 3. So we have something that looks kind of like this. Something that looks kind of like that, okay? One deviation below and one deviation above. Two deviations above, two deviations below, three deviations below, three deviations above. Okay, so this is one deviation above, two deviations above, three deviations above. Negative one deviation, negative two deviations, negative three deviations. Okay, so now it tells me the standard deviation is 3. So this was an ACT score, so these are ACT scores. So 20 was the mean. So if I add 3 more to that, 23 is one deviation above, 26 is two deviations above, and three deviations above is 29. One deviation below is 17 because I'm going from the scores now, so I'm subtracting 3. And then this would be 14 and this would be 11. Okay, so now I have my normal bell curve all set up with my numbers. Remember, between one deviation below and one deviation above. So in this area, so in between these, should have chosen a bigger highlighter. So in this area, so in this area is 68% of my people. Okay, and then we could go another one. You know, if we throw this one into the mix, so if we throw this one into the mix, that green stuff's 95% of my people lie in there. And if I throw one more into this, so if I throw this into the mix, so all the stuff inside that yellow one is 99.7% of my people, okay? So it says what percentage are between, or about what proportion of your data will lie between 17 and 23. So between 17 and 23 is this blue one. So there are 68% of my people in there. What about above a 26? Okay, so above a 26, if I split these in half, this is 34%, right? 34%. If I would have split 95 in half, 95 split in half is 47.5. So from this line over to here is 47.5. And this is lined over here is also 47.5. So above a 26, so that means everything below here, right? So if I know from this middle line up is 50%, right? From here up is 50%. And from the middle line to this green line is 47.5. How much does that leave for the top? So that leaves 2.5% to go from there to there. So above a 26 is 2.5% of my population. Okay, so that's the third one. The fourth one talks about some turkeys. Our turkeys are getting much more fat as time progresses, it looks like. It says the standard deviation for both was 2 pounds, so let's just draw this real fast. So this blue one's going to be 1965. So 1965, the mean was 18. So then I had a turkey that was 20, and one that was 16, and one that was 22, and one that was 14, 12, and 24. So that was pretty much all of my turkeys fit in that population. Okay, but then we come to 1965, or to 2005, and the mean is now 28. Standard deviation, it still says, is 2, so this is 30. That's a 28 in case you can't tell. That's a 26, 24, 32, 34, and 22. So the bottom end, 22 and 22, 24, the bottom end of 2005, that was the top end in 1965. So anyways, what proportion in 1965 weighed more than 26 pounds? Well, 26 pounds was clear up in here. Okay, so 26 pounds, like the proportion in here is like non-existent. It's like 0.01% probably. We're above 4 deviations. So what about in 2005? Well, 26 pounds in 2005 is this area. Okay. So again, I know that 50% is from here down, right? So that's 50%. So if that's 50%, remember these two combined to make 68, so they're each 34. So 50 minus 34 is what remains for this stuff. So this is 16%, that is lower than there, but weighed more than 26 pounds. I don't know why I did it that way. I don't know. Anyways, above 26 would be another 50 this way, plus this 34 would be 84. So together they make 116 and 84, but that's looking at it. So 84% were above 26 in 2005, so 84% were above 26 pounds. In 1965, you might have had like 0.01% of them. Okay, it's just, well, you have 0.03 to split above here, so that's like 0.015 above here and 0.015 here, but that's just above 3 deviations. When you get to above 4, it's like smaller than this 0.015. That's just above 3. So anyways, it's a very small amount that were above 26 pounds in 1965. You might have had an occasional, so like if you had 100 turkeys, 0.0001, you wouldn't even have one out of those. You'd have to have 1,000 turkeys. See, I have to think in pennies. 0.01 of 100 is 1. Yeah, so if you had 1,000 turkey, you'd need 10,000 turkeys to get one that's above 26 pounds, roughly. So 1 out of every 10,000 you might have had above 26 pounds. So anyways, that's section 9.3. These are on your final as well. So I think 3 out of these 4 were on your final. So make sure you kind of have an idea of how to do those. And if you don't feel free to contact me and let me know. Say, hey, I'm not understanding this idea at all. Hopefully between the two of you, you can talk about things and make sure you've got it figured out and work on it that way.